Sounds very low. No, oh, better now. So we are considering an architecture with effectively two storage tiers. The first tier is a traditional parallel file systems, typically Lustre, which is POSIX compliant. That can be combined with a scale-out object store that is non-POSIX. So it typically has an API, which is, in the case of DAOs, the DAOs API, but this talk is broadly applicable to any sort of scale-out object store that are non-POSIX. So it works also with Ceph, that will be using the Redos API, but also with S3. So we are not making any assumption on the size or performance of the two tiers. They have different use cases to use the scale-out object store or the parallel file system. So this talk is not really about when you should use one or the other. We just assume there are two tiers and different use cases for both. The parallel file system is POSIX compliant. The scale-out object store comes up with a different API. And the goal really is to provide an architecture that is really user-friendly, that can be exposed to the user under a single unified namespace. It's really not related at all to burst buffer and transparent caching. The two tiers are really independent. If you run autospace in the parallel file system, you get InnoSpace, and the same thing with the object store. I'm not going to talk too much about DAOs. I will use DAOs as one example. If you want to know more, feel free to ping me separately. So let's go to the next slide, where we have the targeted storage architecture that Intel has been working on for quite some time now. So we have the compute node on the left side, which is connected to the compute fabric, and you have the DAO scale-out object store connected to the compute fabric and directly accessible from the compute node. We have a Lustre file system that is not directly connected to the compute fabric, that is connected through a set of gateway nodes. And we have a new software called I/O forwarding that effectively intercepts all the POSIX I/O calls on the compute node and forward them to the gateway node. The Lustre client is effectively mounted there. So all the DAO's traffic goes directly from the compute node to the DAO's node. But when you want to access the parallel file system, it's intercepted in user space, shipped to the gateway node, and then here you have the Lustre client and you do the system call. And then you have the Lustre protocol over the wire to fetch files, directories, and so on. So this is really the overall architecture we are considering. A few words about DAO so that you can understand some of the challenge we are trying to address here. The first important aspect is that DAOs is really end-to-end in user space. So there is no system call, nothing really in the kernel. It's built over a lib fabric, which is one of the middleware, IO middleware used by MPI to provide low latency communication. And even all the storage is accessed in user space. We use the PMDK for the persistent memory development kit, which provide transaction over persistent memory, against fully in user space. And we have the NVMe user space driver, which is called SPDK. So it's provided in the form of a client library that links directly with the application, go directly in user space to the server, and even on the server side, it writes to the storage in user space. No system call, nothing is happening. The second, as a side effect, we cannot support this drive because we don't have any user space API to access this drive to do full OS bypass. The second aspect to understand for this presentation is that this baseline API here, on top of the storage engine, is not POSIX compatible. It's a new API, which is more like key value store type, object type API. So there is no notion of files or directory or namespace at all. We are integrating this new storage semantics, very rich semantics, directly with all the middleware. And obviously, for compatibility reasons, we are developing a POSIX I/O library that provide read-write operation and namespace management. But this is not fully POSIX compliant. This is why I call it relaxed POSIX I/O. So unlike traditional interface, we don't have the baseline POSIX here anymore. POSIX is just one middleware among any. And since it's not POSIX, the representation of storage is very different from traditional hierarchical namespace. Effectively, we are introducing the notion of storage containers. And a container is really the unit of management and transactions. It's this object key value store API that is used. And then the middleware can store its data model really as it wants. So we can have a flat address space, which is a file per process, as represented there. Or you can organize a hierarchical namespace if you want on top of the data model. But you can have native key value store support, arbitrary connected graph, which are totally different from traditional POSIX. And for the sake of this presentation, what is really important to understand is that a container is identified by a UUID. It means that when you want to open it, you have to find your UUID somewhere and pass it at container open time. Currently, we don't provide any notion of root container or anything like that to organize all those containers. We could do so, but the goal really was to move away from the traditional POSIX interface and not to implement too much POSIX compliance inside this library. So this is why we are looking into leveraging a parallel file system to organize those containers. So from the application perspective, you have a set of containers with different middleware to access those, and you only have a UUID to access it. And the goal is to use Lustre to organize all the data sets. So you have, in this namespace, traditional Lustre files, like moon.mpeg, mkl.so. All the blue names are effectively regular Lustre files and directories. But at some point, you're going to hit an name entry in the Lustre namespace that has a special extended attribute. And this special extended attribute is effectively a specific DAOS attribute that points at the container UUID. And effectively, this is representing, through a directory or regular files, a pointer to an external container that can be found through a different API. So here you have an example of an MPI.io container, another one with a POSIX container, and another one with an HDF5 file, effectively. So from the user perspective, the goal is that it can have Lustre files sitting next to the host container in the same namespace, and it can transparently access one or the others. Obviously, if it is an HDF5 file, currently there is no way through regular POSIX tools to expand the content of an HDF5 file. You already have to go through H5 dump and all those tools. But it's different for POSIX container. People expect to be able to list the content of a container and so. So really the intent is that those things will be seen as a blob, right? And you'd have to go through special tools in order to dump the content. This is done today with HDF5 over POSIX. But for POSIX container, the goal really is to be able to access the content of the container transparently. Obviously, in Lustre, what you have is only that, right? You have directories, files, with a special extended attribute, and this is it. If you just mount Lustre directly, you go through it, you see empty directories and empty files. But this special extended attribute is going to be interpreted by the I/O forwarding layer that I mentioned before. So the unified namespace that I presented before is effectively implemented by this I/O forwarding layer that is represented in dark blue here. So it has several components. On the server side, it has the service that receives calls from all the compute nodes and call into the Lustre client directly here. On the compute side, there is no Lustre client at all, and everything happens in user space. The application sits at the top. It does some calls through a fuse mount point. Yeah, there is a fuse daemon running there, which is managing all the metadata. But as soon as you want to do regular I/O, POSIX, read, write, you could go obviously to fuse, but that's really inefficient because you're going to have to do many data copy. So we have implemented the interception library that links directly with the application with LD preload, intercept all the read-write calls, and send them directly in user space to the POSIX I/O forwarding service, and then access Lustre directly. So this is the regular path when you don't have DAOs into the picture. Eventually, when you have this scale-out object store, with the user space library. The DAO's POSIX library will be interfaced directly with the interception library, and you're going to have all those other middleware there that will be linked directly with the application and provide pure user space I/O directly to the storage. So this is the infrastructure we have built. Now let's look at a couple of use cases. For simplicity, I haven't represented the gateway node. I just represent the interaction between I/O forwarding, Lustre, and DAOs. In the middle there will be a shipping in user space to the gateway node, and the gateway node will be calling into Lustre. But I just abstracted all of this. So if you want to access the content of a Lustre directory, the application will issue a read dir that will be intercepted by the I/O forwarding layer, send it to Lustre. In Lustre, it will turn into a lookup with an intent read dir. It will fetch all the entries if there is any. But then at that point, we don't really know whether it is representing a regular directory from Lustre or whether it's a representation of a directory of a DAO's container. So we're going to have to issue another getX@etr to read the DAO's attribute. If there is no DAO's attribute, it's OK. We just return the content of the read dir to the application, and effectively you are just reading the content of a Lustre directory. Second use case, same thing, except that you are trying to fetch a directory that is effectively a representation of a DAO's container, a POSIX container. So you will still issue the read dir to the I/O fuse daemon that will do the lookup intent read dir to Lustre as before, and then it will issue the getX@etr. The difference is that here you're going to get the special DAO's x@etr that will tell the fuse daemon, oh, actually it's not a regular Lustre directory. It's effectively a representation of a container. And then at that point, the fuse daemon will fetch the content of the directory directly from the DAO's tier and return it transparently to the application. And then the third use case is when you have a DAO's aware middleware that is built natively over the DAO's library. Then at that point, it's even easier. The middleware will just get getX@etr, the special DAO's attribute. It will be turned into a lookup with intent getX@etr to Lustre. We return the UID, and then we have everything we need here to access the container because we effectively retrieve the UID from the extended attribute of the Lustre namespace. So far, I've been talking about what is on the left side, to use regular extended attributes to achieve these goals. So it's great that it's portable. So it's not necessarily Lustre specific, but it has a performance impact, as you may have seen. Every access, even to Lustre, regular Lustre files, require an extra getX@etr. Also, there is absolutely no way to prevent direct access to one of those special directories. If someone mounts the Lustre file system directly, try to create file in there, Lustre will just allow that, right? Even if initially it was supposed to represent a container in the Lustre namespace. In order to address all those issues, another approach would be to modify effectively the LOVEA to store those UUID and basically to have a representation of a container or a component that is external to Lustre, to some extent very similar to what we do with HSM, with the archive ID and so on. The drawback that it's not portable, but that's okay. Minimal performance impact because the LOVEA that represents the layout is fetched automatically on lookup and open. So when we will issue from the I/O forwarding server the extra getX@etr, there won't be another round trip to the MDT, given that open and lookup already fetch those attributes. So less performance impact, very minimal performance impact, almost nothing. And also, with this special layout, we can prevent regular files and directory creation under this special directory, which is obviously something we definitely want to do. So as I said, this is two separate tiers, but we definitely want to do migration. Who is going to trigger migration effectively is depending on the use case. It might be done by the resource manager, by the user, or by some other software. But at the tier level, we want just to provide a way to do very efficient data movement to transform such a tree when you have a special directory representing a POSIX container and a HDF5 container, and to move everything to Lustre. Typically, in this case, we'll fetch this file, move it to a Lustre HDF5 over POSIX, and pull the content of those directory and move it into Lustre. Here, everything is in Lustre. That's traditional Lustre access. Here, you have the special directory that points at the DAO's container. So we want to transform this into this back and forth very, very efficiently. So first of all, there are multiple format conversion that we can consider. The first one is middleware dependent. So here you use the HDF5 version of a DAOs, and you convert it to HDF5 over POSIX. So the data mover has to be aware effectively of the layout. But we're also considering middleware agnostic copy, where, for instance, you just want to take the container, dump it to Lustre, and then eventually just restore it. But then at that point, the format of the container in the Lustre namespace won't be really friendly to any POSIX middleware. We are also exploring how to use effectively the layout swap functionality to implement this data mover and to have atomicity when doing data migration. And I think another feature that was discussed for quite some time is this Lustre client container image, CCI, that maybe Andreas will talk a little bit later. Is basically one of the common issues we have with migration, that we potentially have a huge amount of files to move from one tier to the other one. At that point, the migration required to do a lot of MDT operation. We're going to have to send MDT operation over the wire for every file creation. And this is a problem you get as well with the write-back cache. There was some idea raised by Andreas in the past to be able to use a local LDiskFace image that will be mounted on the client that will effectively give us a high IOPS and file creation rate, because this image effectively is piggybacked by OSTs. You won't have to send a request to the MDT for every single file creation. So this is definitely a feature we can leverage and combine the notion of container we have at the DAOs level with this notion of Lustre client container effectively. And there will be a clear alignment and a very good match between both. So as a summary, so we are working effectively on trying to extend the LOVEA to introduce this new feature. New layout type to point at an external tier in general, which can be generic, and I think we can reuse. This functionality can also be used by HSM, that currently uses a separate extended attribute for the archive ID. Generic based on UID, it can be integrated with any scale-out object store. I use ReadyDAOs as an example, but you can do exactly the same thing with Ceph or any other object store that you use some unique ID to identify a tier, a namespace, a container, or a collection of objects in general. And we are going to explore the opportunity to leverage a layout swap for efficient migration. We have a ticket, LU11376, and we are going to start to actively working on this feature, and there is any suggestion or recommendation, we will welcome any feedback on this. Everything I presented is open source using Apache or BSD license. IO forwarding, DAOs, all those stuff are available on GitHub if you have any questions.
Thank you.
So I found this very, very interesting, and I wonder, or I'm a bit surprised, you know, Intel seems to be still active and doing something. I thought, and that was the general assumption, that everything has been moved over to RAM clients, right? Mm-hmm. So you know, the core team obviously is continuing doing something here, and so this is currently a project, Johann, right?
Yes.
Yeah. So when do we expect, or what is realistic, and then of course I expect answers from others as well, to see this in a future Luster release being implemented?
So I can tell you, on our side, we are starting the development effort right away. Then predicting the landing and the agreement from the community, all those things is always a bit challenging. I mean, even when you're part of the core team, you never really know when your patch is going to land. There are maybe other priority and so on. But definitely, it's something we are working on right now.
Did you get any feedback so far?
I've been discussing with Andreas a little bit, and this is also why I wanted to get this in front of everyone as part of this conference.
So I found it quite interesting. Yeah.
Thanks.
Did you look at possibility to create something like a proxy between asking between a Lustre client and DAOs, like a fake MDT or fake OST, to use an modified Lustre client in this case? Like fake MDT have a prepare a love UA for this client, which a point you shall be read data from OST 10.
So, yeah, we could do that, but then, I mean, as I said, we can just use this this extended attribute, but then it just turns into more traffic at the Lustre level, right?
Yes, but it shall be avoid any modification on Lustre client.
Sure, but we can do better than that, so why not doing something better? I understand what you are saying. Yes, definitely. So you can deal just with extended attribute in a portable way, and the whole point is about optimization and performing better by doing this introduction. And this feature can be reused for other purposes, like
yes,
like
but in this case you will be a store in existing Lustre MDT these attributes.
Yep.
But I talk about creating something like new servers which talk with async and MDT protocol, which use a special feeder range.
Effectively, this is this, right? We could do more work on this server, right? This is the IO forwarding protocol. We could hijack this protocol to have more functionality there. That will effectively be the MDT that you are referring to, I think. This is what you're suggesting, Alexei?
No, I think
Sorry.
about different. About DAOs will be present, and Lustre namespace a special directory with special feeds, like yes, and DAOs is special MDT, like. So Lustre unmodified client will be talk with this MDT or with this current MDT.
So some sort of Lustre on top of DAOs?
Yeah, yes. Okay. Like we have old aged project OST in user space.
Sure, yeah.
So it's in similar case, but not OST, but it's DAOs.
Sure. We can take 10 years of development and do that.
Yes. So I just think.
So what you need to understand is that from our use case, the goal here is to provide very low latency I/O, right? This is why everything is user space. If you have to go through some sort of MDT, Lustre and kernel I/O or things like that, in my opinion, you will lose some of the benefit that you're going to get there. Unless, as you said, if you move everything to user space, you rewrite MDT in user space and LNet and everything.
Yes, I meant to write MDT service on user space.
Sure. If you have any code, I will be happy to try to integrate with that.
We have this code and pass, so we can like to research in.
Sure, but I think all this effort is difficult to reuse at that point.
Thank you. Last question.
This should be quick, but if I understand this correctly, there's nothing, the UUIDs on the special attributes, there's no really Lustre specific piece of that. That could be on a local file system, and they could just have their extended attribute.
Yes, it's external representation, and this is why I think it can be used for the archive ID things, which is very HSM specific and all those aspects. Just a representation of something that is, Lustre will prevent creation inside this directory because it's still something special, but it's represents something externally to Lustre. HSM, archive ID, DAOs tier, safe tier, or anything. But from the Lustre perspective, it has no real understanding of what it represents. And this is the same thing today with the archive ID, right?
Okay.
Thank you, Johann.